Okay, I'm going to go through task 9 and 10, which is a summary of skill set 1, 2, and 3. So first one, anything to the power of 0 is 1. If we've got anything to the power of a half, that means the root of it. So we're going to do the square root of 81, which is 9. Anything to the power of 1/3 is going to be the cube root. So the cube root of 1,000 is 10, because 10 times 10 times 10 is 1,000. 5 to the power of -2. If you've got a minus, that means you flip it. So it be 1 over 5 squared. And don't forget to work that out. So that'll be 1 over 25. Next one, we've got product of primes. So we've got 330. So we start with 330. We want two numbers and multiply to make 330. You could do a lot of different numbers. I'm going to do 10 and 33. You should end up with the same answer at the end. Two numbers and multiply to make 10. We've got 2 and 5. Two numbers make 33. We could do 3 and 11. Both of those are primes. So our answer is going to be 2 times 3 times 5 times 11. No things doubled there. This is a Pythagoras question. So if you've got a right angled triangle and you've got two sides and you're finding a missing side, you know to use Pythagoras. So your rules for Pythagoras is that you square your numbers, you then either add or subtract, and then you square root. You are adding if you need your hypotenuse. You subtract if you've got your hypotenuse. So in this case, we've got our hypotenuse, we've got our longest side. So we're going to subtract. So we're going to do 11 squared, subtract, I almost wrote 3. 5 squared, that is 5, which is 96. Then we're going to square root 96, which is 9.8 centimetres. So I square my numbers, add or subtract, and then square root. Bit of standard form. When you're multiplying in standard form, you multiply your numbers. So I'm going to do 2.3 times 2.5, sorry, I've messed up then. 2.5 times 3, which is 7.5. Then we're going to times our powers. So I'm going to do 10 to the power 7 times 10 to the power 4. So 10 to the power 7 times 10 to the power 4. When we're multiplying our powers, we add them. So this is going to be 10 to the power 11. So we can bring our answer together of 7.5 times 10 to the power 11. When we're dividing, very similar, we're going to divide our numbers. So we're going to do 8.4 divided by 4, which is going to be 2.1. Then we're going to divide our powers. So we've got 10 to the power of 8 divided by 10 to the power of 3. When we're dividing, we subtract our powers. So we've got 8 take away 3, which is 5. So we can then bring it together. So 2.1 times 10 to the power of 5. Next one, a mouse weighs 210 grams to the nearest 10 grams. Upper and lower bounds, whatever we're rounding to, we half it. So 10 grams half is 5 grams. For our lower bound, we subtract. So we're going to do 210 take away 5, which is 205 grams. And for our upper bound, we're going to add that on. So 210 add 5 grams to get 215 grams. A snake measures 2.6 meters to the nearest 10 centimeters. So upper and lower bounds, we're going to take whatever we're measuring to. We're going to half that, so that's 5 centimeters. We want it in meters, really, so that's going to be 0.05 meters in centimeters to millimeters. So for our lower bound, we're going to subtract that. So 2.6 take away 0.05 because it's 2.55 meters. And our upper bound, we're going to add the 0.05 on, so it's going to be 2.65 meters. A bit of indices, so I'm going to multiply my 6 times 7 to get 42. X to the power 7 times x to the power 3. We're going to add those powers, so 7 add 3 is 10. And we're going to do over 2x to the power 6. That just means divide. This fraction just means divide. So we're doing 42 divided by 2, which is 21. And then x to the power 10 divided by x to the power 6. We're going to subtract those powers when we're dividing, so it's x to the power of 4. We're going to convert 5/8 into a fraction again. I think that's meant to say decimal. Apologise. So we've got how many times does 18 go into 5? So this 5, don't forget, is on and on and on, invisible amount of zeros. So how many times does 18 go into 5? It doesn't, so we carry all of our 5. How many times does 18 go into 50? It would only go in twice, so 2 8's giving me 36. That would be a remainder of 14. How many times does 18 go into 140? It would be 7 with a remainder of 14, 7 with a remainder of 14, etc, etc. So it's going to be 0.27 recurring. Adjust to make the standard form notation correct. So this cannot be right because it is not between 1 and 10. So we want to move our number to the left. So it's going to be 6.2 times 10. And we need to take 1 from the power. Now, very careful because it's a negative. So if you do minus 9, take away another 1, it gives you minus 10. So very careful. Okay, task 10. Again, recapping all the skills in skill set 1, 2, and 3. So we've got 225 to the power of a half. So anything to the power of a half is just going to be the square root of it. So you need the square root of 225, which is 15. Anything to the power of 0, no matter what the number is, anything to the power of 0 is 1. Next one, we've got 64 to the power of 1/3. If we've got anything to the power of 1/3, that means the cube root of it. So the cube root of 64 is 4, because 4 times 4 times 4 is 64. If we've got things to the power of a minus, we flip it, it's 1/9 squared. And don't forget to work that out, it is 1/81, 9 squared, 81. Next one, we've got 525 as a product of its prime and index notation. So we start with 525. Oh, it's not letting me type right. 525. Two numbers are multiplied to make 525. Well, it ends in 5, so no 5 goes into it. So 5 is a prime number. 5 times 105 is 525. Two numbers are multiplied. I feel like we've done this one. 105, we've got 5 into 21. And 21, we've got 3 times 7 is 21. So 525 can be written as 3 times 5 squared, because we've got 2 of those, times 7. Next bit, Pythagoras. Again, Pythagoras, we square our numbers, and then we either add or subtract them. If we need our hypotenuse, which is what we do in this case, we're going to add. So if you need something, you're going to add it. If you have it already, then you don't need it anymore, so you subtract it. So 16 squared, add 8 squared is going to be 320. And then we take the square root of 320, which is 17.9. Makes sense, it is the longest side. Standard form, add and subtract in. You write your numbers out of standard form, you add or subtract them, and then you put it back in. So our first one, we've got 2.1 times 10 to the power of 4. 4 meaning we need 4 numbers after the first. So I've got my 2, and then I need 1, 2, 3, 4 numbers. We're subtracting 4 times 10 to the power of 3, so that's 4, and then 3 numbers after the first, so 1, 2, 3. These go 0 when you don't have any more numbers. So we're doing 21,000, subtract 4,000. Obviously you can do that off the top of your head, but I'm just going to show you how I would do it. 0 take away 0, 0 take away 0, 0 take away 0. We need to borrow here. 11 take away 4 gives us 7, and 1. So we've got 17,000, and that's a standard form. We've got 1.7 times 10 to the power of 1, 2, 3, 4. So to the power of 4. Next one, we've got a dividing in standard form. So we're calculating in standard form. We've got 6.9. We're going to divide it by 3.3 first. We take our numbers separately. I'm going to rewrite that. So we've got 6.9 divided by 3.3. So we divide our numbers first. So that just gives us 3. And then we divide our powers. So we've got 10 to the power of 2 divided by 10 to the power of 9. So 10 to the power of 2 divided by 10 to the power of 9. When we divide and we subtract our powers, so when we've got 2 take away 9, that gives us minus 7. So our answer is 3 times 10 to the power of minus 7. A jug holds 1.4 litres to the nearest 100 millilitres. So when we are, we want the upper and lower bounds. So when we're doing the upper and lower bounds, we take wherever we're rounding to, we're going to half that, so that's 50 millilitres. In this case, we want it litres though, so that's going to be 0.05 litres. Lower bound, we're going to subtract that. So we're going to do 1.4 subtract 0.05, so that's going to be 1.35 litres. And our upper bound, we're going to add that on, so it's going to be 1.45 litres. A man's height is 1.8 metres to the nearest 10 centimetres. We half our 10 centimetres, get 5 centimetres. We want that in metres though, so that's going to be 0.05 metres. We're going to lower bound, we're going to subtract that, so we're going to 1.75 metres. And upper bound, we're going to add that, so 1.85 metres. Next one, we're going to do 9x to the power of 5 times 4x to the power of 6 first. So 9 times 4 is 36. When we are working with powers and we're multiplying, we're going to add those powers. So 5 add 6 is 11. And that's over 6x to the power of 3. That's a fraction. So we're going to do 36 divided by 6 is 6. And x to the power of 11 divided by x to the power of 3. We're going to subtract those powers to get x to the power of 8. Next one, we're going to convert 7/12 in a fraction. So we've got, how many times does 12 go into, wonky line, 7. And this goes on and on and on and on, don't forget. How many times does 12 go into 7? It doesn't. We need to carry all of that 7. Our decimal does move just straight up. So how many times does 12 go into 7? It would go in 5 times, because 5 12s are 60. That would give us 10 left over. So how many times does 12 go into 100? That would be 8, because 12 8s are 96. That would give us 4 left over. How many times does 12 go into 40? Well, that would be 3, because 3 12s are 36. That would give us 4 left over. How many times does 12 go into 40? That would be 3. 3 gives us 36. That would give us 4 left over, etc, etc, etc. So it's going to be 0.583 with just that 3 recurring. We need to adjust this to make the standard form notation correct. So it's 67.2. It can't be, that needs to be 6.72. And when our number is moved to the right, we need to add 1 to the power. Very careful, because it is a negative. When we're doing -5, add 1. That means it's going to get a bit warmer, so it's going to be -4. Very careful.